A wonderful good morning, a wonderful good afternoon, ladies and gentlemen. Welcome to our next topic, forward rate agreements, an instrument to hedge interest rate risk, which is also evaluated based on no arbitrage conditions. So you will learn in this section how to use a forward rate agreement in order to hedge the interest rate risk, and I will also present you that the rate you agree in a forward rate contract does only depend on the current given spot rate of interest rates. Let's start with the following situation. You are owner of a house and you took a loan 8 years ago, having an interest binding period of 10 years. That means in 2 years you have to negotiate again a loan with the bank. Currently the interest rate seems to be very low, so it would be of interest maybe to fix the interest rate today and not to take the risk of an unfortunate development of interest rates within the next 2 years. So what are now the possibilities which a bank can offer to you? Alternative number 1, wait and drink tea and wait until you get in 2 years the rate for your next 5-year loan. So here of course you face an interest rate risk as the rates can increase. That would be negative for you. But they can also decrease, which of course it is an advantage for you. The second alternative is to close a forward rate agreement. That means that you today close the contract of a loan whose interest rate is fixed today, but the loan will start in 2 years and will last then for 5 years. So from up to now, the end of the loan will be in 7 years. And that is called an forward rate agreement, which is an interest rate derivative. I will use here the rate of this. I will use for the rate of this loan the expression R small t big T, small t that is the starting point in the future and big T that is the ending point. So in a nutshell, a forward rate agreement is the agreement on an interest rate of a loan on a deposit which is closed today, whereas the deal starts and ends in future. And let's have now a look how can we determine these forward rates, and therefore some slides are available in Moodle for the example which I now will present in the next minutes. Before calculating, let's analyze the situation in one figure. So we have the timeline. The timeline starts today, as today we agree on the forward rate, which is for a deal which starts in small t and ends in big T. So we have to differ between the closing and the bank deal, which has a maturity of big T minus small t years. So let's put that with some examples from the previous slides. So it will end in 7 years, it will start in 2 years, so therefore the maturity of this bank deal is 5 years. And what we are going to do now is to determine what is the rate the bank agrees on today with us in order to close this deal based on no arbitrage. So here we assume that the bank won't make any profit. For the forward rate, we will use our well-known technique either of duplication or of hedging portfolio, consisting of the 3 steps. Create the cash flow of the deal, then duplicate or hedge the cash flow, and at the end apply no arbitrage. So we have generally 3 points of time. We have the point of time today, 0, where we close the respective deal. We have here now a 2-year forward rate loan which starts in 2 years and ends in another 2 years, so at point of time 4. It does not matter whether now you decide to make a loan or to have a deposit with the bank. At the end, the calculated rate will always be the same. So I now assume that here I make a forward rate deposit. So I agree today that I will deposit in 2 years 100 euros. for a rate which is agreed today, and I will receive back in point of time 4, that means after 2 years of this deal, 100 times bracket 1 plus the respective rate power 2. So it's nothing else as the end value of this deal. The question is, how can I now duplicate these cash flows? I have as information the current spot curve, so for every maturity 1, 2, 3, 4, 5, 6 years there's an interest rate available, and what I now can do is that I simply say, let's try to duplicate these cash flows by a simple investment or loan which I take, which leads at the end on maturity date to the same payment as our forward deal. One remark in advance, it is not necessary to use here a notion of 100, so that is simply tradition that I use notion of 100. You can also use 1, 1000, or even if you want a value with some decimals, at the end the result is always the same. So we will have at the end 4 rows, 1 for the deal, 2 for the 2 duplication deals, and row 4 as the sum of the 2 duplication deals. And what is now duplication deal number 1? So here I simply say I want to have a repayment of plus 100 bracket 1 plus the forward rate bracket power 2. Simply replace that by, for example, 104. What do I have to do if I will receive in 4 years from my uncle 104 euros and I want to have this money today? You simply go to a bank, you ask here for a deposit which duplicates this cash flow. So in that case the question is, how much do you have to invest today? That is simply the present value of this value. So I take the cash flow of period 4 and I discount this by 1 plus the 4-year yield in brackets power 4, and I receive here the present value of this payment. I simply assume here that the 6-year rate is 6%. What do I do with the payment of year number 2? So here I will take a loan. Because the payment is negative, I have to duplicate 100 euros in 2 years. Then I simply discount the 100 euros by 1 plus the respective 2-year rate power 2. That is here assumed to be 4%, and in that case I can simply calculate the present value being 92.45 euros. Lastly, I sum up the rows 2 and 3 in order to derive the combination cash flow of the duplication portfolio. So you see in periods 2 and 4 I have the same cash flow, and I have 2 fractions, one negative, one positive. And what is now no arbitrage condition? No arbitrage condition simply says that here the sum in the cell of row 4 and column number 0 must equal the value of row 1 and column number 0. In other words, the sum of this cell has to be 0. I can write this now a little bit different, that I get rid of the fractions. I multiply by 1 plus the 2-year yield power 2, and I multiply also by 1 plus the 4-year yield power 4, and I receive here this equation. In the next step, I want to have the 4-year deals and the 2-year deals separated on both sides, and I also want to get rid of the 100. Then I receive 1 plus y2 in bracket power 2 times 1 plus the forward rate in bracket power 2, that is 1 plus the 4-year rate power 4. What does it mean? Let's analyze that with some colors. If I analyze the 2-year spot deal at the beginning and then I have this followed by a forward deal, so that is the red rectangle, the result will be the same like a direct 4-year spot deal having a yield of Y4. In order to understand that, let's switch before I calculate the result to the next slide in order to show you that by a picture for better understanding what is here happening. Let's assume you want to climb a mountain and until the top of the mountain you need 4 hours. So you have 2 ways for selection. There is one way which has a constant slope, and there's another way where you have first 2 hours which are rather relaxing. What can you expect in the next 2 hours for reaching the top? You can expect a rather exhausting hour number 3 and hour number 4. And that is the idea behind the following picture. I used the following colors: black for the spot deal for 4 years, blue for the spot deal from now to next 2 years, and red for the forward rate agreement. So what can I do? I can simply say I start with my climb of the mountain at a level of 100, and after 4 years I want to reach a level of 124. In other words, I said 124, that is 100 plus 6% of 100 for the next 4 years, so here 124. In my analysis, I will now neglect the interest on interest topic, so that is excluded to have an easier presentation. So here, one investment, 100 euros for 4 years at 6% leads to 124. But I have another alternative. I could now invest into a 2-year deal. That means here I will receive 100 back plus 2 times 4%, that is 108. What would be the result of the other? The result of the other is 112. So here we must accelerate a little bit in the next 2 years. So I add now the line, the connecting line between point of time 2, value 108, and point of time 4, value 124. That is the forward deal. And what does now no arbitrage condition say? No arbitrage condition says it does not matter whether you do directly a spot deal from today until the end of the forward rate agreement, or you decide that you make another deal from today until the start of the forward rate agreement, then being followed by a forward rate agreement. That will lead to the same result. Let's analyze whether we can get a rough approximation for the forward deal. So here we simply say what is the slope in the next 2 years. I say I want to reach 124. I have already reached 108. The difference is 16. So therefore I have now to reach 16 in 2 years. That is 8. In other words, what we can expect as a result is that our forward rate agreement will lead to a payment of 8 euros on 100 or 8%. And we will see that this method can be used as a quick and dirty method in order to calculate fast a forward rate. So what is the respective result? So we have only to amend now the equation that way, that we divide the 4-year return by the 2-year return. We take the square root, deduct 1, and we see as an outcome 0.0804, or in other words 8.04%. That is what we forecasted with our quick and dirty method, applying here the forward rate agreement mountain. And that is also the result which we obtain here. The forward rate is 8.04% per annum. How does now the hedging portfolio for the forward rate agreement look like? So we have again the point of time 0, closing date, 2, start date of our forward rate agreement, 4, end rate of our forward rate agreement. So I took a loan, the loan having a maturity of 2 years, starting in 2 years, ending in 4 years, and the interest rate as a zero bond loan are 2.4% per annum. How can I now calculate the hedging portfolio? I need again 2 deals in order to close all future cash flows to 0. So I start from the end. So I will balance the negative payment from the repayment of our loan. So the minus 100 bracket 1 plus forward rate bracket power 2 by a respective positive payment, that here I make a spot deposit 4 years at 6%. Which leads at the end to a positive payment which balances our negative payment from loan to 0. So simply here again the advice to replace in your thoughts this unknown value by 104 and then simply discount that for 4 years with the 4-year rate in order to calculate the present value of this repayment. Secondly, we have to close the 100 of period 2, so we do that by a repayment of a loan. The loan has a maturity of 2 years and the interest rate of the loan, so here the zero bond yield is 4%. So I will receive today as a payout from the bank 100 divided by 1 plus the respective 2-year rate. That equals a payout of positive 92.45. In the last step, I sum up rows 1 to 3 so that I have in year 4 a value of 0, in year 2 a value of 0, and today a sum of 2 fractions, 1 fraction as a payout, which I have to invest into the spot deposit, and 1 as a positive cash inflow, which I receive from the spot loan. We apply no arbitrage condition. We have nothing to expect from this deal in the future. Therefore, today's value is 0. So we have here the no arbitrage condition, and we simply say that what we have in the cell of row number 4 and column number 0, that has a value of 0. I write this in another way. I get rid of the 100 and I can finally calculate the rate by 8.04% per annum. What did you learn in this section about forward rate agreements? Forward rates are means in order to hedge future interest rate risk. So we had the situation as shown here on the slide that we had the current 5-year rates, and in 2 years our current deal matures and therefore we have to make a prolongation. We are facing a risk of increasing interest rates of a loan, that we have to pay more, but we have also the chance that with lower rates we can save interest rate costs by a cheap refinancing. So what can we do? Either you say, I take the risk, that you simply wait until 2 years and then you close the deal on then the current 5-year spot rate, or you say, I do not want to take the risk, I close today a forward rate agreement which starts in 2 years, ends in 7 years, and the respective rate is fixed today. What is the better alternative? Of course, depends on the interest rate development. It can be positive, it can be negative. We evaluated the forward rate agreement based on no arbitrage condition. We only used the current spot rate, the spot rate from today until the start of the forward rate agreement, and the spot rate from today until the end of the forward rate agreement. By the mountain, I could explain you the no arbitrage condition. So the no arbitrage condition simply says it does not matter whether you invest today until the start of the forward rate agreement, then followed by a forward rate investment, or that you directly say, I make an investment from today until the date of the end of the forward rate agreement. At the end, both results must be the same. If the results are not the same, then you will make an investment, so a deposit into the deal or deal combination which leads to the higher payout, and you will finance that by the deal or by the deal combination which has a smaller payout. Generally, you may ask the question, from which conditions does it depend whether the forward rate is higher or lower? That simply depends what is the relation between the rate with the smaller maturity and the rate of the longer maturity. If the rate of the smaller maturity is also smaller than the rate of the longer maturity, in that case we must compensate more in order to reach the same level. In that case, the forward rate is higher. In case of the rate with the smaller maturity being higher than the rate with the longer maturity, in that case the forward rate will be smaller. Or in other words, if we have a normal interest rate curve, then the forward rates are higher than the spot rates. If we have an inverse interest curve, in that case the forward rates are smaller than the spot curves. So that was now the end of the topic forward rate agreement. I say bye bye until we hear us again for the next audio lecture.